thank Chantal for being there for your patients and being there on behalf of patients everywhere. So thank you. So we're going to pick up on a theme that Anne-Marie brought up and that Chantal touched on, and that's tailoring medicine. Our next speaker is Leif Groop from the Lund University, who's going to speak on precision medicine, the way forward. Leif?
Thank you. Thanks for inviting me, and I actually really like this topic. It's something that I've been struggling with for years. It definitely hasn't been solved. I never finished this one, so I probably can skip it. It was what I'm going to talk about. But I still think that we could really start with the first thing, that, diabetes is a lifelong disease. The diagnosis is based upon measurement of 1 or 2 glucose levels. And it's actually unique in medicine. It's only one metabolite. I will come back to that. I think that when the insulin was discovered by Banting and Best in 1921, this was the view we had. It was diabetes, and that's all. And this is the famous picture of one of the first patients receiving insulin. In the 60s, based upon some experience that some people responded better to insulin, it's called type 1. At that stage, it was actually also called juvenile onset diabetes, and the rest was something else called maturity onset diabetes, or later on called type 2. The question, of course, is, was it really this simple? So I actually wrote my thesis way back in Finland on the heterogeneity of diabetes. And that was actually the first time, based upon one of the patients who came in, diabetes at age 75, of course type 2. A year later, she came back to the emergency clinic with ketoacidosis. And that was actually how the whole story about LADA started. Because we had then, in the freezer, we had samples that we could measure, not GAD at that time, but there was islet cell antibodies. And this was really then, we first called it latent type 1, then we called it autoimmune diabetes in adults, and someone proposed, why don't you add back the word latent, because the latent form. And that was how LADA came. And it's also really in many countries where classical type 1 is relatively rare. LADA is probably the common form for autoimmune diabetes. What LADA really is, people still are debating, but I will come back to that at the end. Then, with the introduction of better refined genetic tools in the 90s and the 2000s, the first genes of MODY, maturity onset diabetes of the young, were identified. Then genes for neonatal diabetes. And so this Swedish patient, Annika, 19 years after 20,000, had to tell, in her case, unnecessary insulin injection. She actually got a genetic diagnosis of a glucokinase-induced diabetes, which is called MODY2. It never progresses, so it doesn't need any treatment. But since you have elevated fasting glucose, you can be diagnosed with diabetes early on. And I mentioned metabolites, and this is actually a way to measure more than just one metabolite, glucose. And you see the different trunks. I think blue is type 2, red and green are some MODY forms. But you see the black ones are that MODY2, and the yellow are the healthy ones. And you see, if we would have had this information way back, we would have seen that metabolically, that mode 2 is completely superimposed on a healthy person. So it's actually a compensated situation because the slight increase in glucose really compensates. This is a picture with the courtesy of Andrew Hattersley, has really been a pioneer in the field. This little guy was born with a very severe form of diabetes. He had a developmental defect. He couldn't walk. He couldn't speak at the age of 2. But then when Andrew and his team identified the mutation in a gene called KCGN11 or KIR6.2, it's actually influencing a gene that it's the target of the sulfonylurea drugs used for type 2 diabetes. So when this guy had an insulin pump but couldn't be controlled with the insulin pump, when they could switch him to large doses of sulfonylurea, they could control completely his diabetes. He learned to speak, learned to walk. So this is, I think, really what you would call precision medicine. So in 2014, where are we? Where should we go? I don't think that we know really all of what diabetes is. And what we read in textbook, we know we have been contributing to that, and that's always old information. So we launched, I think it was in 2008, a project in southern Sweden, Skåne, called ANDIS, All New Diabetics in Scania. We have a sister project up in Uppsala. And you see now the ANDIS project has exceeded more than 10,000. The youngest one is 0 at diagnosis, the oldest 97. And we have also in Finland another registry. Because I really think that we need these observational studies. Because most research, either you are focusing on type 1, you are focusing on children, or you are focusing on type 2. But very few has tried to get the whole picture of diabetes. So if we go in and look, these are the preliminary data. Leave on the, but just look at, because since this registry are linked to the clinical chemistry, patient records, drug prescription registry, now we can get it, all that information. And I wasn't sure, but yeah, there. So you can see, when we looked at the first 4 years, I was surprised to see that males are doing so much worse than females in terms of glycemic control. You can see, if you would look at insulin secretion, you actually get exactly what you would expect over that 4 years. This is C-peptide as a measure of insulin secretion. You see that in type 2, you have preserved. Type 1, you have a clear deficiency, whereas the LADA form falls in between. We can use genetics, as was said, to predict outcome or start to predict outcome. So we are just in the beginning of it. As here, put in just one gene, and you can see that you can either have 2 copies of the red or 1 or 2 copies of the T allele. But also, as I said, we could measure more metabolites than only glucose, as we have been doing with here. If you do what we call a discovery metabolomics, you can basically measure several thousands of metabolites. And now you can see that a picture merging, if blue is type 1 and green is type 2, you clearly can see that they are spread out. Because you can see that LADA is somewhere in between. But clearly, you would like to see, would this person that has been labeled type 1 really be a traditional type 1? Or someone out here with type 2. So I think that the technology is there. We can gain much more information today at diagnosis that we have done. So if we then just here, we were throwing in, doing a cluster analysis, a lot of information. We didn't put in genetics and metabolites still here. But you can see that we have a type 1 cloud here in green, but you also can see that we break down type 2 basically in 4 subgroups. So I think that we are just on our way to redefine the spectrum of diabetes. This will look different in Belgium, in Scandinavia, in Asia. But we need to do this homework. So my view of diabetes is clearly type 1 and type 2 represent extremes on a continuum of a spectrum of diabetes, where we have autoimmunity really in the type 1, and we have the metabolic dysfunction in type 2. But in between, we have a lot of for diabetic patients that we really don't know exactly what is the proportion, what they carry. We know today that LADA clearly is a hybrid. It's an admixture of type 1 and type 2. But since type 1 and type 2 is increasing worldwide, there must be a lot of people inheriting the genetic predisposition to both of these. So what it really will mean for the disease. So my sincere hope is that we would be able to really at diagnosis, invest a little bit more in the diagnosis to really get a step towards precision medicine. Because we also know that future development of medicines, not all people respond to the drugs. They will be too expensive. So we want to give them to those who respond and not to those who do not respond. So I really think it will be a place for, let's say, individualist medicine. And what we really want to do is to come up with, to make a GPS and a roadmap for the diabetic patients. And I actually seriously believe it's possible. And I don't think we have to wait for the next generation. So I just, since I also represent something like an IMI project summit, where we try to do this specifically for diabetic complications. It's a very complicated name of summit, but I think IMI has been tremendous work here to support this kind of efforts. And really, its summit is really a unique enterprise with 6 pharma, 1 SME, and 19 academic centers. And it was probably the first of these 3 diabetes IMI platforms, where Summit, then Imidaya, and Direct. And I think that these projects will also aid us in this. And I will finish with this picture. I don't think it's enough just to see trees. We have to see the diabetes forest.
So thank you very much, Leif. I'm sure that we will come a little bit later with question to you. So I think that so far we realized the complexity